Hi, I'm Tony with Richway Industries, and I've got Rich here with me as well. In today's video, we're putting together a list of 20 questions that we get quite commonly, whether it be through email, trade shows, phone calls, whatever. We thought it'd be a good idea to go ahead and put these list of 20 questions together and make a video where we're going to try and answer them in 20 minutes time. So it's 20 and 20. So we're going to start out. We've each got 10 questions. I'll take a question, give you an answer, and Rich will take the next one, and we'll just go back and forth until we've got all 20 questions answered. Of course, if at the end we haven't given you as much information as you'd like for any given question, or you have other questions, as we tell anyone at any time, get a hold of us. We'd be happy to answer anything we can for you, all right? Okay, here we go. Question 1. I'd like to make panels with cellular concrete. Is this possible? Yeah, it is possible, and we've got a few customers who are doing panel applications with cellular concrete. One of the biggest challenges we run into, or customers run into, is if they're going to make a panel with cellular concrete, will it meet the overall application which you're trying to cast the panel for? Typically, cellular concrete is not going to be quote-unquote structural in strength. So there are many considerations that need to be done if you're going to make cellular concrete panels. Overall, it's just looking at the overall application and trying to figure out if the density you're wanting to produce will meet the requirements of your project.
Well, you scared me with that thing. And here's another question. What are the insulation properties of cellular concrete? Well, cellular concrete is a very good insulator, and the lower the density, the better the insulation value. When you get down to 25, 30 pounds per cubic foot, you're going to have an insulation value of about R2 per inch. As you go over 40 or 50, it's not really a very good insulator. But in fire situations, unlike standard density concrete, it does not spall, so you can use it for direct flame insulation. And in addition to being a good thermal insulator, it's also a very good acoustical insulator. And so if you need more information, get a hold of us.
Question, I guess technically question 3. 2 for me though. How long in terms of time can I pump cellular concrete? This is a good question. We run into it all the time, which is why it made the cut here. Generally speaking though, we try and tell people you want to limit yourself to about 3 hours of pumping time. At this point, the material begins to I don't want to say harden. What's the word I'm thinking of, Rich?
Hydrate?
Hydrate. Thank you. The hydration process has gone to a point where the material begins to get a set, and if you continue to try and pump cellular concrete, or really any concrete for that matter, that's far enough along in the hydration process, you're going to have some detrimental effects to the material. So about 3 hours would be the short answer to that question.
My number 2 question is, how much foam does a gallon of CMX foam concentrate make? In very rough terms, a gallon of CMX will produce 5 cubic yards of foam. You can alter that a little bit by using a lower density foam or by increasing the dilution ratio. Our standard dilution ratio is 40:1, but a lot of our customers are able to get to 45:1 or 50:1. With the equipment that we have here, using the G2 control system, you can alter that on the go because we're metering the foam concentrate into water. And so it makes it real easy to vary that and possibly improve over that 5 cubic yards per gallon.
All right, question 3 for me. What happens if you don't use ASTM C869 foam, which of course is a certification for foam concentrates used in cellular concrete? Most likely what's going to happen if you were to try and produce cellular concrete with a non-certified foam, palm olive, we'll take for example. I tell people all the time, you can use palm olive, joy, whatever you've got for soap, and in our equipment, and you'll probably make a pretty good looking foam. Once you mix it in with a cement slurry to produce cellular concrete, though, you're probably going to end up with a material that doesn't perform. And when I say doesn't perform, you'd have a lot of air bubbles collapse in the, if you're pumping it or just straight placing it, the curing process. So not using an ASTM certified foam is not recommended, because in certain cases you may get lucky and just have a small amount of shrinkage or collapse. In more severe cases, you'd have most of your air volume collapse out if you're not using a good quality foam for cellular concrete.
Okay, here's another question. Will cellular concrete melt PVC pipes? That's a real quick answer. Yes, it will. We have a customer who has had some first-hand experience with that. Their horror story was that the pipes were done by two different manufacturers. One of the pipes didn't melt, the other one did. So you're really kind of on the fringe of looking at a problem. One of the things that is often done with PVC, if you're doing annulus grouting with PVC pipes in a tunnel, for example, is to run water through them. It's important that it be running water so it's carrying the heat away. But the short answer to that question, yes, cellular concrete will melt PVC pipes. The heat of hydration of cellular concrete really can get pretty high. So you have to be very careful with that.
All right, my question 4 is all cellular concrete pervious? This is kind of a tricky one to answer. With cellular concrete, there is pervious cellular concrete as defined as such. To a degree, all cellular concrete is pervious. So if nothing else, it is completely permeable. I guess the biggest thing that we tell people with regard to this question, and this is going to be true of all cellular concrete, whether or not it's designed to be pervious or not, is as the material gets lighter in density, it does allow a higher rate of water to permeate or be pervious to the material. So.
Okay, well, I've kind of altered the order of questions here. I've got one that I had seen earlier. Are there any problems with permeable cellular concrete? The short answer is yes, there are potentially some problems, and I'm seeing more researchers write about the possible breakdown of cellular concrete, permeable cellular concrete, when the material gets saturated and then freezes. The ice then will burst the membrane walls and you'll have a reduction in strength. The other problem with permeable cellular concrete is maintaining the required permeability, because what we're really doing is coalescing the bubbles as they begin to set. And so there are a lot of variables that can go in there, including temperature and other things that can change the coalescence rate and thus change the permeability.
All right, question 5. How far can you pump cellular concrete for abandoned fills? So I've heard of contractors pushing as far as 3 miles with cellular concrete. We've got a customer of ours who had told us once they went 9,000 feet. Ourselves personally, since we do contract a few jobs, if they're within a couple hours of our factory, we did a 16-inch water main abandonment. It was 2,100 feet long, and we pushed that off from one end, pushing some water out and going uphill, which at that point, kind of looking at the pressure on the machine or the line pressure, I think we were only about 35 psi, so we had a lot of room in terms of pressure that we could have pumped further. So generally speaking, though, cellular concrete is chosen quite often for abandonment fills because you can pump such a long distance with low pressure on that material. So,
can I freeze CMX foam concentrate and still use it? Yes, you can. All you have to do is to reheat it and agitate it. This will work very well. We have, for example, a customer in Canada who received 2 totes of foam concentrate by the time it got to them, in the middle of January. It was frozen solid. They used that technique and used it without incident and made good foam with it. So you can freeze it, just heat it and agitate it a bit, and it will be as good as new.
All right, question 6, well, for me anyway, is what is the best way to measure the density of cellular concrete? Best way, I guess, there's a couple different ways I'm going to answer. The best way is to measure the density of the material using a known container, say cubic foot pot or a 1/10 cubic foot pot, taking your sample of material as close to the point of placement as possible, and then again using a scale and weighing it in the pot. Of course, we've got some of the technology in our G2 control, and mathematically there are ways you can calculate density, and some of the things we're looking at to provide that ability from the machine control, but ultimately measuring the material, as I said, at the closest point of placement possible with a calibrated pot and scale is going to be your best measure for QC and cellular density.
What lift height can I get with cellular concrete? A Richway CMX in conjunction with the Richway foam generation equipment, common lift heights range from 4 to 8 feet. It wasn't very many years ago when all specs were requiring a 2-foot lift height. A lot of the work that we did with foam generation equipment, getting a small uniform bubble and a bubble with a strong wall, has kind of driven the whole industry up to where 4 feet is probably the most common spec that we see now. But we have, and Tony mentioned, we do a few contracting jobs. Often we're doing those just for testing equipment, testing material, and because we need to know exactly what our customers are going through. We have done a lift height of just over 17 feet with only about half an inch, I think, of shrinkage, wasn't it, on that one? So, you know, in good conditions, you can get a really high lift.
All right. Question 7 for me. Are there any instances where flowable fill is better? Nope. Just kidding. I'll answer that a little more completely. Flowable fill is a material that we often will compete with if we're talking about cellular concrete, you know, competing with other materials, you know, for fill applications. In certain cases, flowable fill, if you just got a large open void that you can fill off the chute of a truck and you don't need to pump it and you don't need to worry about the excess water that comes with flowable fill and subsequent loss of volume once that water dissipates, then flowable fill can be better in those applications. But where cellular concrete really exceeds is if you're needing to pump it long distances or short distances for that matter. In some cases, cellular concrete can be more economical. I would say in more cases than not, it probably is. So there are a lot of reasons why you would want to use cellular concrete over flowable fill, but you know, there are a couple instances where it can still make a good case for the right material to use.
Another question, how can I improve the strength of cellular concrete? There is no real short answer to this, but one of the first things is that cellular concrete, just as full density concrete, the lower the water cement ratio that you can use, the higher the strength. One of the limiting factors in low water cement ratios for cellular concrete has been that the polycarboxylate water reducers all have a defoamer in them, and so if you use them at very high rates, it tends to break down the foam, and pretty soon you've really got a mess on your hands. One of our current research projects that's going on in our R&D lab is the use of some other more elemental water reducers without the defoamer in them. We can load them up with really a lot of the water reducer, and we're doing work right now to see what kind of water cement ratio we can get to, what the effect will be. In addition to that, there are some exciting fibers. There's one called AC50 that's an acrylic fiber. We're getting a chemical molecular bond there with carbon. You also can use PVA, polyvinyl alcohol fibers. Both of those greatly improve the flexural strength of cellular concrete. And then beyond that, you can go on with a lot of the other admixtures that are maybe a little more common. So there are lots of ways that you can improve the strength. We're doing research. There's a lot more research being done in the U.S., Canada, and throughout the world. If you want to know more about this topic, why, get a hold of either me or Tony, and we'll be glad to talk with you about it. It takes a long time to exhaust all the possibilities.
Okay, so I did not read through my questions prior to doing this. So this next question, I guess, is a little redundant after answering the first, or the question I just answered, rather. This question reads, can you use cellular concrete in place of flowable fill, CLSM, and what is the cost difference? So I kind of answered that in the previous question in terms of can you use cellular concrete in place of flowable fill? Yes, of course you can. And what is the cost difference? I didn't put a number to that because, well, like any cementitious material or any building material, depending on where you're at, your costs are going to be different, across the country, around the world, whatever. But just to give you an idea, for us locally, if we were going to produce 10 yards or 1 yard, whatever volume of cellular concrete, for us to produce that material, including cost of foam, we'd be around $70 a yard to produce that. And I believe flowable fill for us is going to cost $105 a yard. So again, that's just using where we're located at as an example. I would say in general, though, as I said in the previous question, in most instances when we have conversations with people on their local prices, cellular concrete is a price winner.
Next question that I have. How does cellular concrete do in freeze-thaw conditions? Cellular concrete in freeze-thaw conditions does extremely well. We've got the flexibility of the bubbles, so we can take the freezing and kind of absorb the energy without detrimental effects. Our CMX foam has been tested by an independent ASTM accredited laboratory, and it scored extremely well, much higher than was necessary to meet the minimum requirements.
All right, question 9. Can you use admixtures with cellular concrete? The answer in short is yes. The answer in long is you need to test it. We tell people if you're going to use an admixture that we don't have personal familiarity with, you should test it. The best way to do that is to take a 5-gallon bucket of the cellular concrete mix that you would normally be working with and add an appropriate amount of admixture to that. What you're looking for if you're going to have an adverse reaction is material that collapses. Richard mentioned polycarboxylates, which have defoaming agents built in. If you were to take a bucket of cellular concrete, mix in a polycarboxylate plasticizer, you're going to see the foam bubbles after an hour, 15 minutes maybe, just depending on how much you've got in there, just collapse. It's going to be, as I said, a big concrete souffle, and you'll lose 50%, whatever your volume, which certainly would be considered a catastrophic failure of the material. So other admixtures that we've tested, we haven't found any others that I would say have had detrimental effects, but again, we always recommend testing it. We can do that for you as well if you need some help with that, or just have more questions in general on specifics. As of course with any of these questions, get us on the phone if we can help out more.
Do you have equipment for making precast cellular concrete? Well, our CLP series, which is constant low pressure, was designed for producing precast or open fill where there is no change in back pressure. We have several of those CLP machines that are in use throughout the United States and Canada right now. Most of them are somewhat designed for the specific use. Beyond that, we do have a 120 volt foam generator only that's available. If you want to use the foam and dose your own mixer, that's a possibility as well. There are other things, and we are always open to modifying existing equipment, or if we need to, we can work with you and produce something especially for you.
Okay, we've got 50 seconds left. And my last question is, how much does it cost to make a cubic yard of cellular concrete? Again, it's going to depend on your local prices. For us, it's about $70 a yard. Real quickly, the way we figure that is we take, say, our cost for slurry, about $200 a yard. And I guess I should back up and say this is density dependent because your foam is going to be a cheaper portion by far. But we take the cost of 1 yard of slurry, add in the cost of however many yards of cellular we're going to produce, or I guess foam that we're going to add to it, total that and divide it by the total volume. For more information on that, get us on the phone, download our mix design calculator. Rich, you have 5 seconds left.
5 seconds, go. How could I use cellular concrete for non-geotechnical uses? My time is up, but there are a lot of ways. Contact us, and we will talk to you about how you can use it. There are a lot of uses. There's a lot more that is being done from a research point of view in the U.S. and Canada. Some of the other countries use it a lot more than we do here in the United States and Canada.
We appreciate your time. We hope you found this informative. As we've been saying, if you've got other questions, let us know. We'd be happy to do this again sometime if we had a fresh batch of 20 questions. Thanks, Rich, and we'll talk to you later.